Hey, thanks for coming to the talk. So I'm Tracy, this is David. Those are our Twitter handles. We are both tech practitioners, meaning that between the both of us over the last 20 years, we have been building products and systems and services and apps in the location space. We've done well more than a dozen on every platform you can imagine, so phones and web and embedded automotive systems, augmented reality, virtual reality. So between the two of us, we've pretty much done it all in the location space.
And Tracy's gone even beyond that and gotten into the Internet of Things and really human experience with technology. So this is part of what we're going to talk about today is what maps are exactly. What is location data? What do we mean when we say that? It's more than just a printed graphic of a place, but rather a full database. And we're going to talk about the nature of that data and also what thought processes people go through when they're creating map databases, which will
and what thought process they don't go through.
Even worse, right? The bad things that can happen when people leave things out or don't consider all of the repercussions of building a database with a narrow mindset.
Yeah, it was a lot of fun putting this talk together with David. We've known each other for a long time, but David is a real data expert. He's really passionate about nuance and complexities in all kinds of systems, whereas I'm coming more from the other direction, from the front end of products and services back toward the back end. And right. David, in actually the opposite. We meet in the middle.
Exactly, we meet in the middle and think about the user experience especially.
Right. So first, let's talk about traffic, because I think when we want to get you away from thinking about maps and map data and location data as being just buildings and roads and stuff like that, right? So let's think about traffic. Traffic is also a really mature kind of data set that's been collected for decades. And what you're looking at here in this slide is a real state-of-the-art system from 30 years ago, but which is still used quite a lot today. It's two pneumatic tubes stuck onto a road, and cars drive over them, and they're connected to a box, and that box then collects all kinds of data points about the weights of the vehicles, the frequency,
the speed,
the direction, the speed, and stuff like this.
And this isn't used to deliver the kind of traffic information we think about today, the kind of traffic information that you look at every morning to think about your commute, but rather this was from the community side or from the Chamber of Commerce or the city, thinking about how often is this road used. Do I have enough parking? Do I have enough the right kind of zoning rules or laws that are going to help control the demand that I have for this stretch of road?
But it's also interesting because with a lot of things in the data world, the people who are collecting the data are also potential customers for the data. So the city may pay for collecting this data, but then they might sell it to a real estate company to help them figure out where it makes sense to do their suburban developments or something like this. Or so they're using
package delivery firms selling it to automotive companies. Another example.
Right. There are tons of examples.
You can keep going. So next we get to the digitization of traffic information, and this is a little bit more familiar to everyone. All of the different kinds of views that we have when you see the red, yellow, green on the map to let you know how long is it going to take me to get to my friend's house? How long will my commute take this morning? This is all very familiar, but this is, if you think about it, it's only been since about 2008, 2010, when this really started to become ubiquitous, right? It started to become commonplace for us to have this, and the reason is because what used to, for even 30 years before that, there was collection of this information via GPS. on a vehicle embedded in a car, what was a very expensive piece of hardware. Later on, obviously, as the smartphone, as Nokia started to take their dive and Google and Apple started to rise up, what you saw was the proliferation of GPS on smartphones. And this really made it so that the amount of data that is coming across any given minute is immense and amazing. But it gives rise to new opportunities for those businesses. As I pointed out before, data, package delivery services, automotive companies, but of course back again to the cities, thinking about the demand that they have on the different parts of town.
So, yeah, phones are extremely powerful robot cartographers. I mean, the automation of geolocation data collection super exploded with mobile phones. And it's not just about GPS. It's actually less and less about GPS. So even if you turn off your GPS on your phone still knows exactly where you are. I remember actually implementing in 2010 the tools to start collecting Wi-Fi nodes as people are walking around with their phone on when I worked for Nokia. And that database that's now very mature can locate you in a city if your GPS is off by which Wi-Fi nodes you're connected to if you're using Wi-Fi. Even if you have your phone turned off, your location can be found, because if you're using a smartphone, even if it's on airplane mode or your phone is even turned off, it's still kind of checking out where the cell towers are around, so that when you turn it on, it's really ready to use immediately.
And that goes for Bluetooth cellular networks, as Tracy pointed out, and the other interesting, there's a lot of interesting what we call positioning technologies arising as a result of that, right? So there's some that are based on the electromagnetic field of the Earth. There are others that are based on sound. So it's listening, recording sound, and then understanding, maybe you're nearby a train, knowing that you're doing that. So they're really thinking about making that positioning technology much more robust, so that if one system fails, the other one will work in its place.
And the reason that they do that is to make better services for you, but also because it's very lucrative business data to know where a person is. It makes it easier to sell you all kinds of stuff.
So with that, we jump ahead to the car as a robot cartographer. It's becoming more mature of a robot cartographer than ever before. So I mentioned GPS before, and that was when the data was coming as a trickle. Now it is full-blown lidar collecting information in 3D about the roadway as all of the car companies and taxi companies and public transport companies start to become, and they're headed toward automation. That's the promise of all of this, is that you can get more and more automation if you collect more and more data.
So yeah, I think it's pretty easy for, the picture that we try to draw here is that all of us human people out there with smartphones in our pocket, we are a giant sensor network. We're a walking sensor network collecting all kinds of data. We'll talk a little more about that later as well. And now our cars are another sensor network and information network, because by 2020 in the US, I know, all vehicles sold new will have to be equipped with vehicle-to-vehicle communication capabilities. And there's a special band set aside for vehicle-to-vehicle communication. And all of that, as David said, it's about the robots who are driving the cars in the future.
Yeah, the car becomes a mobile computing platform. They're really roving computers that are headed toward superpower, effectively, right?
Yeah, and I mean, all that data that's being collected, there's no end to the amount of data that any system wants or needs, right? If you go back to the first slide with the pneumatic tubes on the ground, it's pretty limited what you can do with that data. It's more or less out of date by the time you finish processing it, right? But the more closer we're getting to real time, the closer we're getting to incredible levels of detail, including in 3D now, becoming really important for the future of augmented reality. The more you have, the more you need. The more you have, the more you need. It's a snowball that never ends.
Yeah, let's think about car accidents, for example. So if in that system that's collecting traffic information, I can also collect the sensor info that says that the driver turned on the windshield wipers. And then an accident occurs, I can now start to derive the fact that that accident may have been caused by the weather. What I'm demonstrating here is just by adding a single additional byte of data, I can now start to infer things that might affect the insurance claim, that might affect the road safety, sending that information back to the city that says that that part of road, when it's raining, is that much more dangerous, et cetera, et cetera. So the domino effect of having more information is obviously very valuable to the marketplace.
So the next upcoming major robot cartographer is the urban fabric itself, right? There have been pilot projects already years ago putting sensors and ad hoc networks onto street lighting, which makes a lot of sense, right? Like from an ecological perspective, light pollution, et cetera, you can easily imagine how if the city doesn't need to turn on the lights on streets that are empty and has a motion sensor attached to streetlights so that it only turns on when it's needed, you're going to save millions and millions and millions of euros in a big city like Berlin.
And so now every tweet, every image, every transaction that happens, whether it's payment with a card or payment now with your phone, starts to generate more and more location-based information. And it's hard to put a finger on something that's not location-based information.
Yeah, if you think about, like, you know, the trash collection, mobile payments, cameras in the grocery store that are coming to be used for, you know, figuring out how old you are and where to send you, which aisles to send you in. You know, the treadmill in your gym is going to know how much you exercise, right? So, in the best case scenario, all of this information is used to make the better possible future for the most possible people. But obviously and unfortunately, all of these systems that can be used to make our lives better and to save our taxpayer money, they also can be used for nefarious purposes. And we don't all, I mean, we know from our work in actually building these systems that not everybody who works in technology remembers to play out the worst case scenarios or ask themselves the critical questions.
Right. So now that we've introduced a little bit about what we mean by maps and what we mean by location data, we can start to take a look at what decisions are made along the way to help to help understand where gaps in information might lead towards these kinds of issues that Tracy's bringing up.
So if you understand that almost all of the data that you're collecting with your phone, with your car, with just living in the urban fabric, if you understand that almost all of the data nowadays has a location aspect to it, you also need to understand that there is no such thing as anonymous location data. It's a pretty tricky problem, because I think every company that does work with location does its best to make sure that it is not possible for people to, for humans to use to get like all of the traces for an individual user. But if people don't go to more than like 5 or 6 places generally, and if you have the location data for a unique user ID, it is really easy to find out who that person is, because they go to work, they go home, they go work, they go home.
Yeah, and when privacy is important to you, then you might not be using any of these location-based features or a smartphone at all. Especially, and we've heard a lot here at Republica conference about cases that are sort of the dystopian nightmare that we've heard so much about. We want to be able to point back and say what kinds of decisions need to be made along the way, not only with respect to data science, but also legal requirements, both for corporations and governments. Those are the kinds of things that we need to have a dialogue about. Absolutely.
Well, I mean, like so many things, as long as you're living in a functioning democracy, you're not really using your privacy for anything in particular, so whatever. But when the day comes that you need it, you might be in trouble.
And we heard a good discussion about the balance yesterday between security and privacy versus convenience, which I think was a very pertinent discussion.
Yeah. Another key aspect we wanted to make a point about is that the data that is collected and the data that is not collected, and the decisions about what we have and what we don't have and how it's used, they're not based on what's good for society. They're not based on what our values and our culture are directly. Indirectly, they are. They're based on who can make money off of what.
Yeah, and as we alluded to a little bit earlier, the more sensors that are installed through the city or installed in the vehicle or installed in the smartphone, the more data opportunities there are. And certainly all corporations are looking at the way to either make more money or save money doing the same thing that they were doing years before as they discover new usage for the data. But because of that, it's really important that we ask those questions, not only of the places where we work, but the teams that we work on, the design of the applications that we're building, but also as consumers, where is that information going, and what value am I getting from it, so that it's a more equitable exchange, basically.
Yeah, I mean, we won't go into a lot of technical detail about how to build in safeties into the system and things like this, but you won't do any of the design work or the technical work to help ensure privacy if you don't think a little bit negative once in a while. And in the practice of building technology, we have really very good intentions, and we tend to be really optimistic. So thinking about, when you think about how to build a system, you always think about the use cases. What is it for? And you design it for what it's for. And I think we need to also start thinking about the misuse cases. And what isn't it for, but could it be used for? For example, there are tons of projects right now to put sensors on service vehicles like taxis and trash collecting trucks and stuff like this. And there are a lot of great things you can do with that, especially in road quality. You can do micro weather. There's lots of great ideas out there. But the same system that you have to create a micro weather system using taxi cabs, it also can be used to spy on the taxi cab drivers, right? And of course, probably would be used for that. So you always need to think a little bit about what's the misuse case that you're building.
And to take it further, there's injustice around the world happening. The part of the scariest stories that you read about more recently are predictive policing, where this kind of information is being used. We have to bring up the point about basing decisions on historic data, trying to forecast based on historic data, which is scary.
Yeah, so now that we've kind of established what's out there and how is it collected and who are the robots in the robot cartography system, we're going to talk a little bit now about all the opportunities you have to really screw it up. So,
so I have to ask the question then: does data have a mission?
Yeah, we had a good discussion about this while we were preparing the talk. David, being a data guy, he tends to think like data's just data is data. And I think that data always has a mission because it doesn't come for free. Data is hard, actually. Data is always dirty. It's a lot of processing. It's a lot of effort. And the purpose for which you're collecting it is the mission of the data.
Exactly. I mean, that's why I don't believe data has a mission in and of itself. It's about the use case. It's about the problem you're trying to solve. But as soon as you take step one to define exactly what your problem is, you're automatically reducing your problem space to a specific trajectory, meaning I'm making a decision that certain types of data are less important for the problem I'm trying to solve. So let's think about the case where I need to, going back to our example of traffic, I need to try to think about the thousands of different types of vehicles that are out on the road, big trucks, little trucks, dump trucks, taxis, bicycles, etc. If I spend all of my time thinking about the data model of how to express every different type of vehicle, then I will never get to solve my problem space of traffic. So what I have to do is narrow my database down to 4 different types of vehicles, maybe single-person vehicle, 4-person vehicle, or 8-person public transit, let's say. So I've picked a few types so that I can start to collect data, but you have to think about what that decision in my data model leaves out. And that's a very simplistic example of one of the first places where bias can come into play.
Yeah, the how you build the model, how you build the database, how you store the data, all of these decisions affect what you're going to get as an output, right? And all of them are opportunities to introduce some kind of bias. I think everybody is a little bit more familiar with the idea of bringing in bias with the gaps in the data, right? So we already explained a lot about how we're creating all these data sets with our phones and our cars and our cities. That means that people who don't have smartphones, who tend to be poorer people, are going to be underrepresented in all of the data sets. People who don't live in cities will be underrepresented.
Right, so you immediately skew the data set even before you collect one bit of actual data because of the model that you're spelling out, depending on the problem you're trying to solve. So it's really hard to tell the future, certainly, but what safety measures do we have in place, either via policy or legal, that can help make sure that we're absorbing that and making it so that we don't hurt people in the process?
It gets even more complicated when we're building these systems with machines mostly to talk to other machines, which is more and more the case, whether it's logistics or automated driving or
smart factories,
whatever. The location data is being used to build maps that are for machines to use, which are completely different than what people need.
That's right. So it's an exciting time, and I think if you click one more time, you should get an animation on these. So these are some of my favorite visualizations of data. It's an exciting time these days for data scientists, for visualization, design, and engineers. But one of the points I talked about just a few minutes ago was that it's also important that we have people with a legal understanding, whether it's human rights and at a governmental level, but also at a corporate level, so that we can have these conversations and we understand what it is that we're building and what implications there might be in case that data gets out or in case that data is misused.
Yeah, now we want to talk a little bit about also the kind of like mind bugs that people have when it comes to these automated systems and the dangers of those. Maybe in this room we're a little bit educated on the topic and are less likely to just believe that an automated system is unbiased or less biased than a human. It's biased in a different way. But in general, people have a tendency to really think that if it's coming from an automated system, then it must be true, and it must be fair, and it must be, without all that human messy stuff, because they don't understand that we've actually baked all the human messy stuff into the system when we built it.
Computers are, we need to think of them more like mirrors. They're reflecting the information that you're putting to them, but in the end, they are merely a machine that helps crunch that information, but it's not making up new information. So we have 5 minutes to go.
So I have a couple of theories about why we have this problem. One is I think that it's just a common, recurring human problem with any kind of new representational technology. It seems like we just get fooled every time. These are famous examples. The first one is the Cottingley fairies, was a series of photos these little girls made with these paper cutout fairies. Sir Arthur Conan Doyle, who wrote the Sherlock Holmes books, completely fooled by these photos. Amazing proof of the supernatural.
That fairies exist.
War of the Worlds, everyone knows about. The 1957 is a television example. It was a BBC documentary about the spaghetti harvest in Switzerland, of all places, that a lot of people also believed.
I love that one.
Yeah, and then of course we're in the fake news zone in 2016.
So it can get to maps too, right? So this is a real map made by the U.S. The NOAA agency in the U.S. This was made in 2011 to reflect the wave action from a tsunami, and you can tell that if you look back here, the measure is in centimeters. Later, this was reblogged after the Fukushima incident, and incorrectly captioned saying, "Watch out for the radiation from this fallout," and just to show if you're skimming through your timeline, you can be fooled relatively easily, and people were panicking over this and not actually reading, or someone has cropped the map and cropped the bit about the most important information out of the bottom, which is just another quick example of that.
So aside from our problems just interpreting that a representational technology could be saying something that's not true, I think we also have a real difficulty understanding that things don't exist outside of context, and I blame Plato for that, who's having a moment. He's been name-checked in 2 of the talks I heard yesterday. It's wild. So the idea that there is a reality that's true behind the messy reality that we experience with our senses is one of the worst ideas to ever hit humanity. And it prevents people from I think if you understand that things don't exist outside of context, that there isn't a contextless reality, everything has its own purpose, its own context, its own story behind it, then it makes it a little bit harder to fool you.
Yeah. So we talked a bit about where the bias originates, especially in data models, considering what data are you leaving out, what data gaps exist, but also how are you processing the data, how quickly are you delivering the data. All of these things can lead us to a case where you have less and less success when it comes to what you're trying to accomplish, but also perhaps even worse, leaving people out or harming the humanity.
Yeah, I think people in this room are probably pretty on top of the idea of where bias can originate. Maybe we've brought a couple new ideas about the ways databases are structured and the technical side. Another idea that I think is important is that I am trying to think about a lot lately is how are we planning to predict the future when all we have is data from the past, and usually the data from the past is full of garbage.
Right. Yeah, so it gets back to the case that I mentioned was predictive policing. So thinking about if you have poor or even worse, corrupt police practices over time, and you're finding that certain neighborhoods have more arrests and you're sending more police there, it may not be that more crime is actually happening in that place, but rather that you're sort of self-fulfilling the destiny of that neighborhood.
So we're going to get into a little bit now the conclusion, but what can you do? What's going to happen? This is one of the things that I'm really optimistic about with automated systems and AI is that it's something I've been a little obsessed with for the past 4 or 5 years, and in recent years I hear people talking about it much more intelligently. It's the kind of conversation around the topic has really evolved, and this is from last year at Tech Open Air. Cassie Koshikov, who is one of my favorite people, she works at Google, she was doing a small talk on a side stage and somebody said, "How can I learn about AI?" And she said, "You don't need to learn about AI, AI needs to learn about you." The point being that we need to fill those gaps in the data sets that we have from the past so that we can build better systems for the future. Right. And what does the future hold, right? What does the future hold? So
maybe we can jump right ahead to the.
I think I want to say the thing that you were talking about, that when we were working on this talk, it's just very easy to slip into dystopia, right? When you look at the systems that were built, like the drone, the Alphabet drone, the Wing drone that's just got an FAA approval, and they show it delivering bagels to some happy middle-aged suburbanites. Like, okay, that's awesome, but that drone can be used to deliver other things than bagels, right?
And there are certain people that are sensitive when drones are in their airspace, right? It's true. Absolutely.
Yeah, so it's kind of a joke and kind of not that I sometimes say that I think that maybe the best case scenario is that the next murderous dictator rises up really soon in the West and uses all these tools that we've put in place, and then people start to give a shit about their privacy again. Maybe we have a bloody revolution and we start over with a better attitude.
I hope not. I hope we don't get that far.
Yeah, that's like a worst case, best case.
But Tracy's very good, as she pointed out, thinking negative first so that we can try to build up the best case scenario. So I think we mentioned this quite a lot about how to consider where our bias gets introduced. I think we're getting
if you get rid of that platonic. Okay, last idea. The most important idea actually is that you need to stop thinking that it's possible to build an unbiased data set or an unbiased system. And instead of thinking about how to build a system without bias, think about how you're building a responsibly biased system. And that can be the last words.
That's good. Thank you.
We